This is the 2.6 lesson. The objective is that you will be able to solve absolute value inequalities. The first couple things on the notes, it seemed a little confusing. Whenever we're talking about these absolute value inequalities, whenever we see this symbol, so let's say we have some kind of absolute value going on, and we have this symbol, this is going to be an AND statement. Alternatively, if we have an absolute value and we have a greater than symbol, it's going to be an OR statement. And we're going to kind of see some examples of that as we're going through this. As we were talking about in prior lessons, we flip the inequality when we multiply or divide both sides by a negative. And where that comes into play whenever we're talking about this is whenever we're evaluating these, we actually have to kind of stay a little bit cautious of these. As we're going through this, you're going to see a few examples of us kind of flipping the sign, because we effectively kind of multiply both sides by a negative in order to get one of the possible answer kind of branches. You're going to see that as we go along, so let's just get into it. All right, so for these ones we're going to solve the inequality, and we're going to graph the solution if at all possible. There may be times where graphing that is not feasible for us. So here we go. So when I have this, I have y, the absolute value of y plus 2 is less than 8. As we said up here, that automatically tells me that I'm going to have an AND statement. You may remember from whenever you did absolute values back in the previous chapter, we kind of take this kind of different approach in that we're going to do both a positive and negative value of this. And so what we actually wind up getting is we get y plus 2 is less than 8. And then we also kind of effectively multiply the whole thing by a negative, and we get y plus 2 is greater than negative 8. And so maybe adding on to this flipped inequality, multiply it by both sides by negative, or evaluate an absolute value. So we flip those. Now we solve. So we go we chop 2 from both sides, and you can actually do it for both parts of this at the same time if you so desire. You can definitely split these up and do them one by one. That's totally cool. So y is less than 6, and y is greater than negative 10. Now, a lot of times whenever I do this, I like to double check my work and make sure that it actually worked out right, especially this right one. So I'm going to put in a number that's greater than negative 10. So I'm going to say negative 9. And so if I do that, the absolute value of negative 9 plus 2, absolute value less than 8. That's the absolute value, negative 7. Oops. Is less than 8. The absolute value of negative 7 is 7, which is less than 8. That's a true statement. If I did 10, it would actually wind up equaling 8 exactly, and that's actually not a feasible answer for us. I'm looking at my graph, and it might be a little short. So what I'm going to do is I'm actually going to go by 2s. You can kind of do what you want with your graph as long as you don't skip numbers. So I'm going to go negative 12, negative 10, negative 8, negative 6, negative 4, negative 2, 0, 2, 4, and I was still a little bit, 8. Still a little off on it. That's fine. So when I look at this, I'm going to start with, let's just say y is less than 6. So I go to 6. It's a less than. There's no equal to, so I fill in the dot. And a number that's less than 6 is 4, so I'm going to the left. y is greater than negative 10. So I go to 10. Oops, these are not filled in dots. I'm just getting my head to myself just a little bit. Oops. There we go. That should be an open dot. And that's an open dot. And it is going to the a number that's greater than negative 10 is negative 8, so we're going to the right. I don't know if I can get that. Nope, I can't. All right, we'll leave it for now. All right. Okay, we're going to do another one. The absolute value of q divided by 3 is greater than 2. So again, whenever we're doing this, we're kind of doing two different equations. We're doing q over 3 is greater than 2, and we're doing q over 3 is less than negative 2. So we start evaluating this, and the way that we get rid of dividing by 3 is we multiply by 3. And we're going to do that on both parts of this. So we're going to get q is greater than 6, and q is less than negative 6. So I'm going to get my handy dandy pre-made number line. Again, I'm going to go by 2's. I think this one might actually work out. But starting at negative 8, negative 6, negative 4, negative 2, 0, 2, 4, 6, 8. Hey, it fit. That's a negative right there. So I have a dot at negative 6. And q is less than negative 6. A number that's less than negative 6 is negative 8. So I'm going to go towards the negative 8. Q is greater than 6. So I go to 6. A number that's greater than 6 is 8. So I'm going to go towards that 8. Number 3 is a little more challenging. In it has some more aspects to it that we haven't really addressed too much, though you should at this point be a little bit familiar with them. So you'll need to remember that whenever we're evaluating absolute value, we want to get the absolute value by itself, and that also applies to whenever we're doing this kind of like specific inequality math. We need the absolute value to be by itself before we try finding that other kind of the two different options. So I'm going to evaluate this as far down as I can, and then I'm going to do those two kind of like separate ones. This first part, they stay the same. So I'm going to subtract 10 from both sides. And so I get 3, absolute value of 2a plus 5, that's a 5, is less than or equal to, that makes this 27. Then I divide both sides by 3. So I get the absolute value, divide by 3. And so I get the absolute value of 2a plus 5, absolute value, is less than or equal to, that's 9. This is the point when I actually do the two different equations out of this. So I get 2a plus 5 is less than or equal to 9, and 2a plus 5 is greater than or equal to negative 9. Now I continue it. So I subtract 5 from both sides, I get 2a is less than or equal to 4, and I subtract 5 and subtract 5, and I get 2a is greater than or equal to negative 14. And you could do one side and then do the other if you want to. I like to kind of do them both at the same time. Now I'm going to divide by 2. And a is less than or equal to 2. Divide by 2, divide by 2. A is greater than or equal to negative 7. So now I'm going to make this a little bigger. And we're going to paste that in. And if you wanted to, you could totally, at this point, you could be like, hey, you know what? I'm going to graph these independently, and then I'm going to combine them. I kind of do it all at once. I'm going to be actually extending this past it because I don't like having that weird 7. So I'm going to go -8, -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3. So we're just going to continue this out a little bit. So a is less than or equal to 2. So filled in dot at 2 and going to the left because 1 is less than or equal to 2. Then a is greater than or equal to -7, another filled in dot, and we're going to the right. And these guys actually wind up meeting up, and they have this kind of shared space in between them. Next one, y minus 3 is less than or equal to 4. So in doing this, I say, okay, the absolute value is actually by itself already. So if I were just rewriting this again, less than or equal to 4. I can do kind of right off the bat my two equations. So y minus 3 is less than or equal to 4, and we also do y minus 3 is greater than or equal to -4. So we start solving this. So I add 3, and I do the same thing over here. Again, you can do these separate if you want to. I like to do them together because you're doing the same steps. So y is less than or equal to 7, and y is greater than or equal to -1. If I go and grab my number line, let's see, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to start on the left. Y is less than or equal to 7. So that fills in, it's a closed dot. A number that's less than 7 is 6, so I'm going towards the 6. Now I do the next one. Y is greater than or equal to -1. Again, closed dot. A number that's greater than -1 is 0, so I'm going, and they actually wind up meeting up. Number 5. As I mentioned a couple questions ago, we want to get the absolute value by itself before we start trying to evaluate it. So I get the absolute value of 3 plus r, absolute value minus 4 is less than 0. I'm going to add 4 to both sides, so I get 3 plus r is less than 0. Oops, not 0, sorry. That's a positive 4. I'll change it in the notes later. Now we can start evaluating this. So this is the same as 3 plus r is less than 4, and 3 plus r is greater than -4. Going to subtract 3 from all parts. I get r is less than 1. And I get r is greater than -7. I'm going to go in, Control V. So going to start at -8, 7, -6, 4, 3, -2, -1, 0, 1, 2. Man, all these are just like perfectly too far for my graph. So r is less than 1. So I go to the 1, I do an open dot, because there's no equal to sign. A number that's less than 1 is 0. I go to to -7, again, open dot. And I go, a number that's greater than -7 is -6. Finally is number 6. Number 6 is one of the ones that you kind of want to keep your eye out for whenever you're doing this. The reason why is the way that this winds up working is we're trying to do the absolute value of a negative number. You may remember if we did the absolute value of x and we said that was -1, the answer here is no solution. Because there's no way for us to get a negative value here, because this is simply saying how far away from 0 is x, and you can only have a positive answer. So we can't get a negative answer here. Same thing applies with this. The catch, like it was before, is we need to make sure that we've gotten the absolute value all by itself. In this case, we have. If you were to, let's say, not recognize that, that's totally fine. It's not something that you might not recognize right off the bat. You could still go through and you could solve this, and you'd actually get, whenever you went back and plugged in an answer, you get an answer that wouldn't work because you wouldn't be able to get less than a negative. If it's at 0, it works. You get kind of a partial answer if you do greater than a negative, and it actually kind of almost winds up being all numbers at work for that. So just kind of one of those to keep an eye out on. That concludes the lessons. So go ahead and check out what your assignment is, and have a good time.